Hello everyone. Yeah. Hi everyone. Hello. Am I audible?
Hello. Can anyone confirm whether I'm audible or not? Yeah, I think we'll wait for 5 more minutes and let's see if anybody joins. Then we'll start. Yes, can anybody confirm whether the screen is visible or not?
Yes, sir.
Okay, fine. Thank you. So let me start. This is NOC EE-62. Okay, just hold on. Yeah, hi. This is NOC EE-62. This is basic electronics, just to make sure that you guys are joining the right course. This course is taken by Professor Patil from IIT Bombay. I am Debashish Nandi, a course TA. I am a PMRF scholar in IIT Kanpur. The purpose of this tutorial is to make sure that you feel comfortable doing the assignment problems, also get any doubt you are having regarding the session or the topics I am covering, you get it cleared. So I will be hosting this session every Sunday from 3 to 5 for the next 12 weeks, including this one. So this will be the modus operandi for the for this tutorial. So what I expect from you guys that at least you should have attended the lectures. Otherwise, this will not be serving any purpose. I am expecting that you guys have gone through the previous week lectures, which has been posted on the course web page, and it is getting updated. You are also getting email notification, I presume. And also that you should have attempted the assignment problems, at least one from your side, right? That will be very helpful. So what I expect from you during the session is that you please keep your microphones muted all the time. As I will be explaining the topics or solving problems, you may use the raise hand option in the Zoom. I think we all are familiar with the Zoom platform by now and this video conferencing. So you please raise hand for the options, and after each and every topic or each and every question, I will be giving you time to ask your doubts, and then onwards we can move on to the next topic, right? So, and also this will be a 2-hour session, as was evident from the first slide. And also one thing that at the end of this 2-hour session, I will give you 10 to 15 minutes to ask your general doubt regarding this. So even in case you miss some doubts, some topic, something to ask, or something may come up in your mind at a later stage of the during this session, so you can ask during that time. Is that fine? So just if I ask you any question, you can unmute yourself and then answer, or you can just reply on the chat, right? It will be difficult for me to check the chat during the session. So that thing I will do at the end of 2 hours. So if you feel you like to stop me somewhere, you just unmute yourself and make your query, right? And you use the raise hand option. That will be very helpful. And also I urge you to keep a scientific calculator handy and solve the problems along with me. That will help you to get the confidence, right? So make sure that you are having one scientific calculator with you. Just again, I am asking whether I am audible and the screen is visible. Can anyone please unmute and confirm?
Yes, sir, you are audible.
And also the screen is visible?
Yes, sir.
Yeah, fine. Thank you. So this session, as you might have seen, the session is being recorded and it will be posted in certain web page in the YouTube channel. And this will be, the details will be shared to you by the NPTEL team over email, right? So let us move to for the first week. This is week 1. So what is my plan for week 1 is to introduce the basic concepts with you, right? As this course is of basic electronics, so I will be going very slow, and because I think this course is generally taken, at least I have taken it during my UG first year. So I think many of you will be just coming up after 12th. So I will be going very basic and very steadily. And also if you feel to feel any change is required in my pace of explaining, please let me know, right? So let's start. So let us, I think this is visible to you. We'll be starting with question number 1. Let me just zoom it up for you. So what they are asking, that a circuit is given, right? I can see there are 2 voltage sources, 1 current source. What they are asking us to find the voltage V2, right? This voltage when only this source is active. This source is active. So I think you guys are familiar with the concept of superposition, right? So superposition theorem will be required to use. So we will be using here superposition theorem. Okay, so let me brief you about the superposition theorem. I think you guys all know the superposition theorem as you might have gone through the lectures, but let me tell you the salient features, right? What you should keep in mind. First thing you should keep in mind that superposition theorem is applicable to only linear networks. This is very important, right? By linear network, for the time being, we will be dealing with resistors and control sources. Can anyone please unmute and tell me why the control source is a linear element? Anyone? Okay, I'll explain it. Then this resistances and control sources will be dealing with as the linear network. Then what superposition theorem tells that it takes into account one independent source at a time while nulling or deactivating effect of other sources. And lastly, what superposition theorem does is that it adds up the effect of all the above possible cases keeping in mind about the polarity, right? This is very important. So let me first tell you why control source is a resistance. You all know, right? Resistance is a linear element because suppose I have a resistance and I apply some potential across it. There will be some current which will flow. So if I see the IV plot, it will be passing through origin and it will be a equation of a straight line, right? And the slope will be 1 by R. It is a constant slope, so it is a linear thing. Now let me tell you about the control source. Let me take one example of VCVS, voltage controlled voltage source. Suppose there is another voltage source in the network. So what you will have here, suppose VI, and this is AVI, right? This voltage source. Then what is my input in this case? My input is VI. And what is my output in this case? Let us call it VO. So you can see that depending upon the value of A, we will again have a straight line, right? So these control sources are generally considered as linear elements. Okay, let me know if you do not get this point. This is very important, right? What is linearity? Linearity means it is between input and output. So in this case, my input was this and output was this. In this case, my input is this, output is this. The linearity talks about only between the input and output. It may be voltages and currents. It is not strictly that IV has to be linear. It is always that input and output relation should be linear, right? The system should be linear. Please keep this point in mind. So our superposition, for our case, we will consider this linear network, which will consist of these resistances and control sources. So let me copy this circuit. That will do. Okay. So here in the question, they have mentioned that we are required to find a certain component in the circuit, that is V2, when only VS1 is considered, right? And VS2 and IS are deactivated. So I have mentioned here that nulling and deactivating of the other sources. So let me first explain nulling or deactivating sources. What does it mean actually? If I have a independent voltage source, right? This is node A, this is node B. Let us say it is VS. So nulling means my VS should be 0, right? Now VS is 0. What does that mean in the circuit parlance? In circuit parlance, it means it is a short circuit. That means between point A and B, there is no voltage drop. Similarly, say if we have a current source, independent current source between node A and B, and we are nulling it or deactivating, it is the same term. IS equal to 0. These are the two nodes A and B, right? If there is no current through this branch, right? If there is no current through this branch, then between A and B, there will be a open circuit. So this is what we mean by nulling or deactivating independent sources. Anyone have any question regarding this?
No, sir.
Okay, just hold on a minute. Where did it go? Okay, so that I do not think. Okay, let's move on from here. I think nulling or deactivating is clear, right? In this question, we have asked this is not present and this is not present. Then what will be my V2? Then I can draw an equivalent circuit. Some of you may already know this very basic steps, right? Please bear with me, because I am explaining it for those also who have just started their graduation. So see, this is a voltage source, right, between these two nodes. So I will need to short this. And this is a current source present, which I need to deactivate. That means I need to open circuit this. And I am required to find this voltage V2, right? So we can see that these two resistances are in parallel, and this is in series with this. So if I draw another equivalent circuit, this 2K and 2K parallel will give me 1 kilo ohm, right? You can cross check it. And this is my 10 volt voltage source. So the potential drop at this point will be, V2 will be 1 kilo ohm by 4 kilo ohm plus 1 kilo ohm into 10 volt. So it will give me 1/5 into 10 volt. That means 2 volt, right? So due to VS1, effect of VS1, my V2 is 2 volt. So in this case, the correct answer is B. Okay. I think you should not have any question regarding this. Even if you have, just let me check if there is any raised hands or not. Okay, fine. So let me move on to the next part. This is again the same circuit, but here we are asked to calculate it when only VS2 is considered and VS1 and IS are deactivated, right? That means this is deactivated, and only VS2 is present. So if I draw the equivalent circuit, VS1 is a voltage source. I'll make it a short. This is my resistance. This is a open. Current source is deactivated. This is my 8 volt. This is 2K. This is 2K. This is 4K, right? So we are asked to find potential between points, say, let us name it AB. So again, this and this resistances are in parallel. So my equivalent circuit will become this is my AB, this 4 and 2, 4 into 2 by 6, 8/6, 4/3, right? That will be around 1.33. If I am not wrong, that is 1.33. So this is 1.33K, this is 2K, and this is 8 volt. So my V2 or VAB for this case is 1.33 by 3.33. So it is coming around 3.2 volt, right? So here the correct answer would be 3.2. I think this is pretty straightforward. Let's move on to question 3. Again the same circuit, but now we have to calculate it for IS. and these are not present or deactivated. That means this is a short
Sir,
yes, please.
sir, sorry for interrupting. Actually, this is a basic doubt. So can you just let me know how to find the series and parallel combinations when there is a source interruption?
There is a source.
When there is a source in a loop, so how can we find the series and parallel combinations of the resistors? I need to let you.
Just let me open a blank page, right?
Okay, sir. Sorry for this basic doubt, but
no issue. This is basic course, right? You are free to ask doubt. So let me source. Which kind of source you want?
So yeah, in the previous case, there is a current source, and we just open circuited it, right?
Right.
So in this, how do you say that 4 kilo ohm and 2 kilo ohm are in a parallel combination? So
Okay. Right.
Just
Just let me.
Then why shouldn't the 2 kilo ohm resistor and 2 kilo ohm resistor shouldn't be a parallel combination?
Okay. Fine. This is a good question. First of all, let me just copy this circuit then. Let me copy this part.
I am familiar with the voltage division rule and all, sir, but this is something.
Okay, fine. Just let me tell you one thing, right?
Okay, sir.
Treat the elements. This is an element, network element, right?
Okay, sir.
A network element is connected between two nodes. It can be a resistance, it can be a capacitance, it can be an inductor or anything.
Okay,
this
sir.
is a two node between two terminals. There is between two nodes, there is one component is connected. When we talk about circuit analysis, what we check is the potential between these 2 points, right? VAB is VAB is VA minus VB, and current is also in this branch, right? So always remember, whatever we measure is between two nodes, right? Now in this circuit, you see this is a node, this is a node, right?
Yes, sir.
We need to see how this between these two nodes, what are the components?
Okay.
This, if you see, this is a node.
Hello?
A and node. Hello. Is it audible?
Yes, sir. I was not interrupting. Somebody else.
Okay. Rajesh, can you please mute yourself? Rajesh Kumar Datta and Sarvanan. Okay, thank you. So see, this is node A and this is node B, right?
Yes, sir.
What components are connected in between? One is 2 kilo ohm resistance. Another thing you see, this is also the same node. This resistance is connected in the same path, right? 4K.
Yes,
okay.
Sir.
But in between, you see, this is a node, right? This node, let us see C. Node C and node C. Why 2 kilo ohm and why this 2 kilo ohm and this 2 kilo ohm won't be in parallel? Because these components are not between the same node.
Okay. Got it. Yes, sir.
Did you get it?
Yes.
So you need to check between any two nodes, what are the component that is connected, right? So that is why
sir,
this
then
4.
you mean like sorry.
Please
yes,
go
sir,
on.
Yes. Yes, sir.
No,
Sir,
please go
like
on.
if there is okay, sir. So if there is any two elements between two nodes, then that would be a series connection, right? Sorry, that would be a parallel connection, right?
If
You mean?
there is any number of elements between two nodes, we will see only two nodes, right? See, for the sake of it, let me see if there is another resistance, right? Let's say 1K. Then what happens if I see A and B? Between A and B, this is my parallel connection. This is one connection, this is another connection. Now it is a different case how to handle this case, right? Similarly, between A and B, 2 kilo ohm is parallel with this, and this is parallel with this entire component, right?
Yeah. Yes, sir. Yes, sir. Yes, sir.
Okay, then
I got
you
it.
had another question.
Sir, then you see the 2 kilo ohm resistor in the node between A and C, right?
Okay, yes.
So how would the connection would be for that 2 kilo ohm and 2 kilo ohm? Is it series?
Okay.
Sorry.
See, no. You see what you should do. See, why didn't I consider of this 2 kilo ohm resistance at the first place, right? Because see, you have these formulas when you have resistance in series, right, and resistance in parallel. You need to simplify your circuit, right? Here you see that between A and B, you do not have this 2 kilo ohm anywhere. This 2 kilo ohm is not between A and B. Here you need to find this potential, right? Between A to B. So what you need to do is between A to B, you need to find out the equivalent resistance. Then you see that it is just a series combination, right? So you deal with this 2 kilo ohm at a later stage. First to simplify between A and B, whatever simplification is possible.
Sir, okay, sir. Let's say that. Let's forget everything. Let's consider the node alone, like A, B, and that voltage source 8 volt. Okay.
Okay.
So in between A and B, there is a 2 kilo ohm resistor, and from A to the voltage source in between, there is a 2 kilo ohm resistor. So so the connection would be parallel, right?
Just
Let's consider the loop alone.
Okay.
Let's considering the loop alone, A, B, and that voltage source.
Which one? A, B. This side you want me to remove? This side?
Sir, yes, sir.
Okay.
If the loop like this, then
this is a series combination, right?
Series combination, yes, okay.
This is a series combination because you see the current flowing through the circuit is same.
Circuit, okay.
Right?
Yeah, sure, okay.
Okay. So, okay, let's move to next part.
Thank
So
you, sir.
in
Thank
this,
you for hearing.
okay, no issue. For this question, what we are supposed to do is you keep this IS, which is 1 milliampere of current source. This is 4 kilo ohm. This is 2K and this is 2K. As I said, this is nulled, so this is short circuited. This is short circuited because these are independent voltage sources. So let me simplify this network. See here also what we see between these two nodes, I need to find the voltage, right? This voltage I need to find out. So what I'll do, I'll just make this a parallel combination between two. This is 1 milliampere. This is 1 kilo ohm, parallel combination between these two. And this is 4 kilo ohm, right? I need to find out the voltage across this resistance, right? So how can I do the voltage division? I need to see the current division. This current is flowing in this path and this path. Let's do the nomenclature like this is I1, this is I2, right? So how much current I2 will be flowing? It will be simply the opposite resistance by total resistance into 1 milliampere, right? So it will be 0.8 milliampere current I2, and I1 will be your 0.2 milliampere. This is also evident, right? From this point, if you stand here and see that you have two paths to go. One place you have much more resistance, another place you have a smaller resistance. So more current will be dragged into this loop than this one. So that is also evident from the result that I2 will be more than I1, right? So I2 is your 8 milliampere. So what will be my V2 in this case? My V2 will be I2 into 1 kilo ohm, right? That is 0.2 milliampere into 0.8 milliampere into 1 kilo ohm. It will be my simply 0.8 volt. So your correct answer would be this one, B. So now we have seen that we have calculated V2. Let me add another page. Okay. So now if we see, just copy it and paste it. Now if you are asked to find out what is the total V2 when all of these sources are present, right? Then how will we go about it? First, let us take the first problem case when this voltage source is present. This is my open circuit. And this is null, right? This is 2K, 2K, this is 4K and 10 volt. Here, this is A, this is B. Let me say this V2 has come up to, this V2 has come up to 2 volt, right? This V2 has come up to 2 volt. Then the same circuit with VS2 is only on. This is my open. VS2 is only present. In this case, you have 4K, 2K, 2K. This V2 has become 3.2 volt, right? Note the polarity. And another case when only my IS is present, right? So this is my null. This is 2K, this is 2K, this is 4K, this is 1 milliampere. Here V2 between A and B has come up to 0.8 volt. So what will be the total V2? You see, when I wrote the statement in the first slide, right? Is it visible? Yeah. When I wrote this statement, right? Add up all the effect of the above possible cases, keeping in mind about the polarity. This is the final step of the superposition theorem. So you see, in this case, what we have done, we have to use superposition. when taking one source at a time active. First case, this is active and others are null. Second case, this case is active, this source is active and others are null. Then this source is active and others are null, right? So your total V2 would be 2 volt, and see the polarity are always the same between A to B. A is positive and B is negative. So it is 2 volt plus 3.2 volt plus 0.8 volt. It comes out to be 6 volt. So my total V2 is 6 volt. Let us keep this data in mind. So moving on to the next problem, what it is asked that in this circuit, what is my V1? So what is V1? Drop across this resistance, right? So how to go about it? There are several ways to do. One possible solution is use superposition. As the same way we found V2, you can found V1, right? The same way. That is one way. Another way is you notice that this is a loop, right? So if I talk about only this loop, and apply KVL here, right? Because my KVL is valid across any loop. So if we apply KVL in this case, so what we have using KVL, let us take minus to plus sign of voltage. We go around this way. Minus to plus sign of voltage is negative. So minus VS1. Then we have V1, right? Plus V1. Then we have V2, right? V2 is equal to 0. And we have, what is VS1? My VS1 is 10 volt. I need to find V1 and V2. We have calculated it to be 6 volt. See here, it is not mentioned we have to consider for one source. So we have to take account of the entire V2, right? So your V2 is 6 volts, right? So we can calculate my V1 to be 4 volt. So see, if you have to use the superposition, then you have to do 3 cases and then you have to do adding up all of them. But as we have already done the exercise for V2, so we can directly find out my V1, right? So this will be, A will be my right answer. So this is very basic thing. I think do you have any doubt regarding this? Any one of you can raise hand or unmute themselves.
Sir, if V2 is not known, then we have to go for the superposition thing, right?
No. V2 is not given. If
yes, sir. Like previously, we find V2. If we didn't find V2, means we have to
the
go
sequence of the sequence of the matter has come out to be such that we already have the V2, right?
Yes, sir. Yes,
so
sir.
we use the KVL to just simplify our calculation. Otherwise, you can use superposition theorem. You can use KCL. These nodes you can use KCL. There are so many ways to go about it, but this is the simplest one.
Yes,
So
sir.
when you will be doing your assignments or in future any circuit analysis, always keep in mind that what tools you have and what information you have. If you look the circuit carefully and you are aware of the tools means this KCL, KVL, nodal analysis and all, then you can solve the circuit very quickly, right? So this is what for question number 4. Moving on to question number 5. So what does it say? In this circuit shown in the figure, what is the Thevenin voltage seen? Okay, so we have to be topic is Thevenin's theorem. Okay, so let me start. Suppose you have a network, right? This is a network, and you are only given access to these 2 terminals. Usually, you are not concerned about what is inside this. What is inside this, you are not concerned about, right? This is a black box given to you, and you can access only these 2, A and B port. This one port, A and B terminals, right? And this network has resistances, control sources, and independent sources, right? Then this network, as far as the node voltage and currents are considered, currents are concerned, then if I draw this circuit in this fashion, okay, if I draw this circuit in this fashion, suppose this is your RTH and VTH, and you are given A and B, and this I and VAB, let's say, are same. And again, you do not have the access into this internal thing, and you are given these 2 boxes. Say this is box 1 and this is box 2, and you are told that what you have is this access to these 2 terminals, right? And what you are told that VAB for both the cases are same, and I are for both the cases current going into node A are same. Then you cannot differentiate between these 2, right? These 2 networks will be just the same. You cannot say in which box you have these components or which box you have these components. If you open it up, then only you may be able to see, but otherwise you cannot distinguish between these 2, right? So these kind of circuits are called equivalent circuits. What Thevenin theorem tells us that if you have a linear network like this, and if you have controlled sources, by the way, let me tell you, controlled sources are not independent sources are not linear, right? And that is let me give you an home task about it. You find out and prove the similar way I have shown earlier, right? This concept, this linearity concept. You take independent sources and make yourself believe that it is not linear. So what are the condition of linearity? It should be a straight line and it should be passing through the origin. Means when 0 input is provided, 0 output will be the output. You draw the IV characteristics of this control sources and make yourself believe that these are not linear element, right? So what Thevenin theorem tells that these are linear elements, and this is independent sources if present in a network. It can be simplified by this equivalent circuit. There will be one Thevenin voltage and one Thevenin resistance, right? So how do we prove Thevenin's theorem? The basis is look at the terminal voltages and currents. Okay, and you use superposition theorem. Superposition theorem to prove Thevenin equivalent circuit. This can be done and this is very easy, but due to the time constraint, if I have time at the later stage of this tutorial, I will definitely explain it. Otherwise, you can look it up into YouTube. You can find some reference. Also, I think Professor Patil might have explained it in his lectures. So you should be aware of this Thevenin's theorem proof, right? It is very interesting and it will give you some good insights that how superposition theorem is the basis of Thevenin's or Norton's theorem, right? So let me go into the applied part. What I will do, I will explain you how to calculate this VTH, that is Thevenin voltage, and RTH, that is Thevenin resistance. So just let me add another page. Okay. So Thevenin voltage, how do we find it? Suppose you are given a network which have some sources and some resistance. What you need to do, you need to find out this voltage, right? VAB. Sorry, Muthuraj, can you please unmute and ask your query? Have anything been posted on the chat? I think no. Okay, if you do not have any query, so let me continue. So this VAB, you know, the terminal voltage is your basically Thevenin voltage. And we'll see how to calculate this thing, right? This is very straightforward calculation. And this is your RTH. RTH is the series resistance connected to the Thevenin voltage source, this resistance, right? The way to calculate this is you stand here and look into this terminal. Okay. Look into this terminal and see. And one thing you need to do is null all the independent sources. But you should not tamper with control sources or resistances, right? These things you keep as is, but you make the independent sources go to 0. Independent sources go to 0 means if there are any voltage sources, that will be short circuited, current sources, that will be open circuited. Same thing, nulling concept, it is coming again and again. So you should be very accurate and you should be very familiar and you should understand this concept very clearly. What does nulling or deactivating means, right? And you look into this terminal, this A and B terminal, and measure the equivalent resistance. We'll see through an example. And this VAB is your open circuited voltage measured between A and B. Okay. So in the question, it is asked that we need to find out the Thevenin voltage as seen from A and B. Let me copy this circuit. Okay. So, okay, how to go about it, right? What you need to do, you need to find this voltage, nothing else. This is your VTH. To find this, you need to simplify this circuit, right? See, between these two nodes, not these two nodes, this also can be done, but let me go in a easier way. Between these two nodes, what do we have in this side? Between these nodes, we have a series resistance and a voltage source, right? This is of 5 volt, this is of 5K. Let me say this is some P and Q node. And there may be some other components, other network connected there also, right? So this can be simplified excuse me. In this fashion, this current will be 1 milliampere. This resistance will remain 5 kilo ohm. Now this is called source transformation. Tell me if any one of you has any doubt regarding this source transformation, or I will explain it if you have any doubt or do not understand any particular topic.
No doubts in source transformation, sir. That's
source transformation is clear?
Yes, sir. That's super clear. But I don't know the concept of Thevenin. Let me go through it. That's not a problem.
Okay, fine. So the source transformation is clear. Then what I can do, I can just redraw this circuit as this is a current source, this is a resistance. What do you have? 1 milliampere. This is 5K. Then we have our current IS current source, that is also 1 milliampere. Then we have a resistance 2.2K. Then we have this network. B, this is 4.7K, this is 3.3K, this is 1.5K. Okay. So we need to find out the open circuit voltage between these 2 points. So can anyone tell me what will be this voltage? Is, let's say, R and S, VRS in terms of VAB, let's say. Can anyone tell me? Aravind?
Sir, can you repeat it again, sir?
And the question is that what will be the voltage between point R and S?
R and
in terms
S.
of VRS, basically this voltage.
Okay, sir. Okay,
in terms of VAB.
VAB, yes, sir. VAB, okay. We can use voltage divider rule, sir.
Why will you use voltage division rule?
In order to find VRS.
See, remember, this is my open circuit, right?
Okay, sir.
I need to find this open circuited voltage. This open circuited voltage, you will find this term in the book, right? The Thevenin voltage is the open circuited voltage looking between the terminals. So what does the open circuit voltage mean actually? It is not simply the voltage between that. It is not simply the, if I put a voltage source, there is no voltage source, right? What this means that in this branch there is no current.
Okay, sir.
If there is no current, then if there is no current through this branch, that means VRS will nothing but be VAB.
Yeah, similar. Okay, sir.
Is it clear?
Yeah, sir.
So in Thevenin theorem, you have to be very careful to not commit this mistake, right? If it is open circuited voltage and you see a resistance hanging at the end, you
Sir.
do not consider that. Yes. Rajesh, yes.
Sir, मतलब 1 ampere current source and 1 ampere current source are add up and then these convert into again voltage source transformations with the help of you.
Okay. We'll see about it. But I was talking about this point, right? What will be my VRS in terms of VAB?
Okay.
So you always find this term in the book. So I just wanted to make sure that you do not commit this mistake. You do not commit this mistake. This open circuit voltage means this terminal is open circuited. That means you do not use any voltage source. What Arvind was telling, that he sees this as if I put a voltage source and if I just tell you to be concerned about this much of the circuit, right? Then what you will see that there is a series resistance of 3.3K and 4.7K. You will simply use voltage division, right? But here it is not the case. It is an open circuit, so no current will flow. This VRS will be equal to VAB. This thing is a very common mistake for the beginners, so please don't commit this in your assignment problems and in future courses, right? So let me see how we can simplify this circuit further. As Rajesh has said that here we see two current sources in parallel. So we can just simply add it up, right? Is it clear to everyone? Is it obvious? Is it obvious that two current sources in parallel should be added?
Sure, depending upon the positive and negative, the arrow marks. So if they were similar, we can add it up. Sorry,
No, add it means add or subtract. It can be done.
Yeah.
See, this is I1,
sure.
This is I2. So your net I can it be written as this one single source with I1 and I2?
Yes, sir.
I think so, yes. But in case, but in this case, there is a resistor, so I don't think so.
No. See, again, Arvind, again, you should only consider the nodes, right? These nodes are the same nodes.
Okay, sir.
Okay, these nodes are the same nodes. So it can be added.
Yes, sir.
This is the same case, what I am showing here. Now, can anyone tell me what happens if this is the case? This is very interesting. I could not resist to ask you this question. I1 and I2 are not same. How will it be? What current should flow?
So this case is, sir, invalid.
No, but if I connect it, let's say if I connect it, you are absolutely right. This is not permitted. It is invalid. Not invalid, it is not permitted. And why it is invalid?
Because, sir, two current source having different magnitude and maybe burned, sir.
No burning. The issue is that it is a series combination, right?
Yes,
in a series combination, the fundamental principle is your current should be same throughout the
circuit
branch.
Yes, sir.
Right. So here in the same branch, in the series combination, you are having two in different current sources, right? So it is not permitted. But let me tell you, this can be done, and this you will face in later courses, but with a certain tweak that you consider some parasitic capacitance and you consider the equivalent charging and discharging. This thing, I am not explaining it here in detail, but remember this, that as Rajesh has said that this is not valid. For this course, I cannot explain it to you in much more detail, but this is not valid. Similarly, voltage sources in series, are they allowed?
Yes, sir.
Okay, right. So it will be
V1 plus V2.
V1 plus V2. And similarly, this is also not allowed, right?
Yes, sir. Because parallel branch have a same voltage.
Yes. So this is also not allowed. Okay. Keeping this in mind, if we move on to this case, so what we see? We see a parallel combination of 5 kilo ohm resistance, 2.2 kilo ohm resistance. Then there is 4.7K, 1.5K, and 3.3K. 3.3K. But as I told you, this potential, this resistance, we should not be concerned about, because this is my now VAB, because it is open circuit voltage. And this is my, what is the value of this current source? Anyone?
2 milliampere.
Right. This is 2 milliampere, right? So now to further simplify, see, we need to find out the potential between these two nodes. You should keep in mind and simplify accordingly. So these two are in parallel. So what I can do, I can simply this is my 4.7K. This is my 1.5K. And this is 5 parallel 2. So 5 into 2.2 divided by 7.2. It will be 1.53. 1.53K, right? So now I need to find out potential between these two nodes, right? So see what is happening. A 2 milliampere current source is flowing here. So this branch current will be 2 milliampere. Now you see, if you stand here, what are the ways you have to go? You have for you to go. You have this way and this way, right? So there will be a current division. Let us call it I2 and it is I1. So what is the resistance seen in the I2 path? It is a series combination between I 1.5 and 4.7, right? That is, it is seeing a 6.2K resistance, this path, and this is seeing 1.53K. So what will be my I2? My I2 will be simply 1.53 by 6.2 plus 1.53 into 2 milliampere, right?
Yes, sir.
So if I calculate it, this divide by 6.2 plus 1.53 into 2, it comes out to be around 0.4 milliampere. So what is my VAB? 0.4 milliampere into, no, it is this, right? I need to find out the voltage between this. So it will be 4.7 kilo ohm. So this into 4.7 kilo ohm. So I am getting it around 1.86 volt. You are okay with this, right? This milliampere thing and kilo ohm thing.
Yes, sir.
One is 10 raised to 3 and another is 10 raised to minus 3. So it is getting 1, right?
G.
Okay, fine. So 1.86 is the VTH. So did we have 1.86 as an option? Yes, we have. 1.86 is the my Thevenin voltage. So your Thevenin voltage VTH is 1.86 volt. Moving on to the next question, the same circuit, I think, yes, but we want to find the Thevenin resistance, right? So how to find Thevenin resistance? We have to null this, and then standing here, we have to see this way, what is the resistance, right? So let me quickly do the circuit. This is short, okay? So this will be bypassed and this will be open. So this is my, for your convenience, let me draw it in this way. This is 3.3, this is 4.7, 1.5, 2.2, 5, right? So what is my VAB? I want Arvind to tell. Arvind, if you are there, can you please help me doing this?
Yes, sir. Yes, sir.
First, what should we do?
Sir, first we have to simplify the circuit, sir.
No, right, that is right. Where should we start?
From, sir, I can't understand the question, sir. Where should you start?
What is the first resistances we should minimize?
Sir,
simplify.
4.7 and 3.3, sir.
4. Yes, sir.
No. How?
5 and 2.2, sir.
Exactly right.
Yes, sir.
5, you can see, right? There's between these two nodes, you have simplification. Here you have the complexity, right? How can you just do this? Because these are not between the same nodes. Again, this is very important concept. Understand, simplification can be done if the elements are between the same node, right? Just let me, this 4.7 is between node small a and small b. 3.3 is between A and capital A. How can you simplify this? You cannot, right?
Sir, can I ask you?
Yes, please.
5 ohm and 2.2 kilo ohm are parallels, and then its combinations will be series with 1.5 ohms, and it's parallel with 4.7, and finally it's series with 3.3 kilo ohm.
So you are absolutely right. Is everybody clear? Is everybody clear about it? Aravind?
Yes, sir. Yes, sir. I know, sir.
No, you
Yes,
understand, right? Why can we cannot start from 4.7 and 3.3?
Yes, sir. I know. Yeah, we have to start from 5 and 2.2. Yes.
No, you have to start that. Don't remember that you have to start from 5.2.
No,
you need to
yeah.
check the notes, right?
Yeah, notes. Okay. Yes, sir.
That
Yes,
is
sir.
very important.
Yes, sir.
So if we simplify this, first we will do this simplification. Okay. So let me calculate. I think we have done this earlier also calculation. Yeah, 5 and 2.2, right? It is 1.53. So 1.53 plus 1.5, that is parallel with 4.7. Then that is in series with 3.3. So this is 3.03 in parallel with 4.7 in series with 3.3. So 3.03 into 4.7 divided by 3.03 plus 4.7. it is giving you 1.84 plus 3.3 plus 3.3, right? It is giving you around 5.14 kilo ohm. So your correct answer is this, right? D. So your RTH, Thevenin resistance, is 5.14 kilo ohm. Okay, I think this is pretty simple, and let's move to the next question. Here it is asked that what is the maximum power that can be transferred to a load resistance RL. So the topic is maximum power transfer theorem. Can anyone tell what is maximum power? If you are familiar with maximum power transfer theorem or not, that will help.
Can I ask you, sir?
Yes.
Maximum power theorem transfer apply when load resistance must be, if resistive, then it will be equal to the source resistance.
Why do you know?
Because sir, maximum power transfer then when source resistance equal to the load resistance.
How this comes about, do you know?
Yes, in this this circuit can be simply
No. How do you know that it is maximum power is transferred when RL is equal to RTH or the source resistance, right?
yes, sir.
Let me just brief you, right? It will help in future. So what is power? Power is
I square or
I square R, that you can say, or let us say be more specific, V into I. This is very general, right? V is IR, then you write I square R. Okay. So
yep.
Now let me write what is PRL. That means this resistance, this voltage VRL into the current IRL. Okay. Current
Yes.
through this resistance. VRL into IRL. What is VRL? It is nothing but voltage division.
Formula voltage across a load.
Load, this is the VRL.
Yes, sir.
What is IRL?
VTH by RTH.
Okay.
Yes, sir.
So what is my total power then? VTH square divided by RTH plus RL square into RL. So now if you are asked what is the condition on this power when it will be maximum with respect to RL, what should you do?
मतलब DP बटे DRL बराबर 0 for maximum.
DRL equal to 0.
Yes, sir.
Do you know why this is so?
Yes, sir.
Why?
Because maximum minimum conditions.
That is fine, but why at maxima it is 0? Why at minima it is 0?
Because denominator will be 0. So
No.
Suppose
Suppose
minimum this for maximum.
no. Let me just tell you in a different way. What does this mean, by the way? This is y, this is x. Okay. What does this mean? Dy by dx at, let's say, any point. At not point, let's say at x equal to x naught. Let's say this is x naught. What does this mean actually? This means the slope, right?
Yes, sir. Slope.
This means the slope of the curve at that point, right? Now see at maximum, what is the slope? Anyone? What is the slope at maximum?
1, sir.
It's 0, right? What is 1? 1 slope will be a line passing like this with 45-degree slope, 45-degree angle. If a line is like this, it has a slope of 0.
Because 90 degree.
No, not 90 degree. It is parallel to x-axis.
0 degree.
It is 0 degree, right? And what is the slope here? 0 degree means your tan 0, right? Tan theta, tan 0 is 0 degree. And what is the slope of this line, vertical line?
190 degree.
No. Tan 90 is what?
Is equal to 1.
Tan 90 is 1.
No, infinite. Sorry.
Infinity, right?
Yes.
So see, when you have a maxima or minima, right? That means at these points, you have a slope of 0. That's why to find the maxima and minima, we put this dy by dx equal to 0, right? Did you get it?
Yes, sir.
Then again, to differentiate between maxima and minima, we double derivative it and check whether it is, if it is maxima, right? Say it is maxima, then around this point, it is falling, right? And if it is minima, it is rising. So if you again take a derivative at this point, it becomes negative and this becomes positive. That's why you see for maxima, d square y by dx square is less than 0. And d square y for case of maxima. And for minima, it is less than 0. Sorry, greater than 0, right? For minima, it is greater than 0. This is the reason. So now we need to maximize this thing, right? These things you should be very clear. This will give you more better clarity of the subject, right? So this dPRL by DRL. So if we take dPRL by DRL, what do we get? We can treat it as one function and we can treat it as another function. So in first case, we derive derivative with respect to RL. That means the second term, this stays. And another case, this 2 RL VTH square by RTH plus RL whole cube. And you make it to 0. This cancels. And you see RTH plus RL equal to 2RL. Then RTH equals to RL. That means when your RL will be equal to RTH, maximum power will be dissipated, will be not dissipated, let me not use that term, delivered to RL, right? Now, what do you do when you have multiple sources and you do not have one single voltage source? What do you do then? Anyone?
First of all,
What
sir,
do you do?
first of all, we find one single voltage source, that is VTS.
How do you do that?
VTS, sir, find.
How do you do that?
With the help of source transformations, yeah, network theory.
No. Just what is the theorem I just talked about?
To VTH or RTH.
What is the theorem?
Thevenin's theorem.
It's Thevenin's theorem, right?
Yes, sir.
You use Thevenin theorem to convert this network to a single voltage source and a series resistance. This is the application of Thevenin theorem.
Yes.
Then you need to, if RL, it is suppose a RL is connected here, the maximum power will be delivered to RL when RL is equal to RTH. And what was our RTH? 5.14, right? So if RTL equal to RL equal to 5.14 kilo ohm, then maximum power transfer will happen. And what is the maximum power, by the way? See, this is my P formula, right? So your PRL equals to VTH square by RL plus RTH whole square into RL. When maximum power transfer theorem is valid, then P max will be equal to VTH square by RL. RL is equal to your RTH, right? So RTH plus RTH whole square into RTH equal to VTH square by, this will be your 2 RTH square, that will be 4 RTH, right? What was your VTH? We have found it in couple of slides back, right? It is 1.86 volt. So it is 1.86 square by 4 into 5.14 kilo ohm. So it is coming out to be 1.86 square, 1.86 square divided by 4 divided by 5.14. It is coming out to be 0.168. What is the unit here?
What?
See carefully. What is the unit of the voltage?
Volt.
What is the unit of RTH?
RTH
RL.
ohm.
RTH is?
Ohm.
No. What is, I have written it here, right? It is kilo ohm.
Kilo ohm, yes.
So this will be what? Milliwatt, right?
Yes.
This 10 to the power 3 will be 10 to the power minus 3. Then it is a milliwatt. Be very careful about the units. So did we have that option? Yes. 17 milliwatt, 0.17 milliwatt. This can be treated as 0.17 milliwatt, right? Then in the next question, let us move forward. In the circuit shown here, this, okay, there you have a control source. What is I2? I2 is this current they want to find out, right? So let me tell you a statement and listen very carefully. I can solve these statements rather than we can solve this problem many ways. One way is use KVL. Another way is use KCL or KVL, KCL, they're combining as nodal or mesh analysis, right? What should we choose between nodal analysis and mesh analysis? How do you go about it? Can anyone have any idea?
Nodal analysis.
Why?
Because two nodes A and B are present here, and we can simply apply nodal analysis.
So maybe
No,
due to the current source. Maybe due to the current source.
No, it is a control source, right?
Okay.
This whatever you are telling is right. But there is much more deeper reason. Why should we use nodal analysis? Suppose you do not have two nodes, you have thousands of nodes. What will you do? Can you imagine a situation where there will be thousands of nodes? Anyone? Why do you care about thousands of nodes, right? In the first place. Have you seen any circuit like this, only with two nodes? See, let me tell you, the mobile phones you are using, right? It has microprocessors. I assume that all of you are electronics or electrical engineers. So it has microprocessors. Microprocessors has transistors, right?
Yes, sir.
Transistors has 3 or 4 nodes. Some of them have 5 nodes also. Let me begin with it. Let us say 3 nodes. And how many transistors do you have in a microprocessor? Can you guess?
Thousands.
Thousands. Anyone else?
Millions.
Millions. Anyone? It has 1,000 crores of more than 1,000 crores of transistors nowadays. Not 1,000 crores, 100 crores maybe. Let us take it as billions, 10 to the power 9 number of transistors into 3 nodes. Can you imagine how a circuit designer will just simulate or just analyze the circuit? How does they do that? Can they do hand calculation? No, right? They cannot do hand calculation on crores of nodes. What they do, they use circuit simulators. I think Professor Patil will introduce to you about SQL. I think this IIT Bombay simulator, right? You have gone through the course template also. So the circuit simulators, and let me tell you, the circuit simulators simulate any circuit by using nodal analysis. Okay. So nodal analysis is more important in our case. You should know mesh analysis also. It comes handy sometimes, but the major focus should be how do you deal the nodal analysis, because that is how the circuit simulator solves the large circuits. They just convert it in the matrix form and they do use Gaussian elimination to get the inverse of the matrix. We'll see about that. So we'll use nodal analysis, right? That is one reason. Another reasons you have said also, by looking at the circuit, we can see that there are 2 nodes. So it is easy for me to calculate the node voltages. Screen is not visible. Gautam Kumar. Can anybody confirm whether the screen is visible or not?
Okay, screen is visible for us.
Screen is visible, sir.
Okay, I think Gaurav might have some network issue. I think Gaurav, you can disconnect and connect again, then you will be able to see. So how we go about solving this circuit? We have these 2 nodes, right? Let me use a different color. These 2 nodes. And C is a reference node. I can assume it as a ground also. It doesn't matter because I need to measure some voltage between 2 nodes. So C is just a reference node. So how can we solve this using nodal analysis? So at node A, I will be using KCL, current coming in, current going out. So 4 milliampere is equal to, let me tell, this is VA and VB, the node voltages, VA minus VC, which is ground, by 1K, right? Plus VA minus VB by 2K. This is my node 1 equation. So if I multiply this kilo to this side, it will be just volt, right? So let me just do that. So 2VA, this is 2VA plus VA minus VB is equal to 8. That means your 3VA minus VB is equal to 8. This is my one equation, one node equation, node A. What about node B? Current coming in VA minus VB by 2 equal to, sorry, another component current is coming in GV1 plus G is given 0.5 millisiemens, right? So 0.5 into V1 is equal to VB minus 0 by 500 ohm or 0.5K, right? 0.5. Just to have the continuity or consistency in the units. So this is VA minus VB, right? And this will be multiplied plus V1. What is V1? Or V1 is VA only. So VA equals to your VB into 2 will be going this side, so it will be 4. That means your 2 VA, that means your 2 VA will be your 5 VB, right? That means your VA will be 5 by 2 VB. Did I do some mistake? VA minus VB is by 2. VA minus VB by 2.
Sir, how did you put that 0.5 into VA, sir?
This is right. This is GV1 current.
Okay, sir, GV1.
G is given 0.5 millisiemens.
Okay, okay. A question I
And
just
VA is
Okay.
V1. Okay.
Okay, sir. Okay, sir.
So we have what this is. What did I miss? This is VA, VB, 2 into this is 1. That means VA, and this is 4 VB, right? 4 VB. So, okay, you have 2 VA. So that means VA minus VB. No, not 2 VA. VA, 5 VB. Okay, then VA is equal to 5 by 2 VB. Okay. So then here it is 3 VA. VA is your 3 into 5 by 2 VB minus VB equals to 8. That is 13 by 2 VB equals to 8. That means your VB is equal to 16 by 13, right? Did you get the same thing?
On the video.
Did you get the same thing?
Sir,
Anyone?
actually, sir, 1 divided by 0.5 is 2, sir. You put 4. VB into
No,
4.
it is 2, right? See,
Okay.
what I have done, I have just multiplied it here. So it has become 1, and this will multiply it here also.
Okay, sir. Okay, sir.
It will be 2, right? So VB is this. VA will be 5 by 2 into 16 by 13 volt. That is your 8 and 40 by 13 volt, right? So what is my I2? I2 is this current. That is VA minus VB by 2K. That is your VA is this, VB is this. So 24 by 13 into 2 milliampere. That will be your 12 by 13 milliampere. What does it come to be? 12 divided by 13 is, sorry, 12 divided by 13 is, 12 divided by 13, 0.92. 0.92 milliampere. Do you have any option regarding that? Yes. So I think this is pretty straightforward, right? I think you guys are comfortable with this KCL. Okay, Raja C, can you please mute your mic if you do not have any question to ask? Raja C, I think. Okay, let's move on. So again, the same circuit, we need to find out I3. So we have our VV. So your I3 will be simply VB by 0.5 kilo ohm. Your VB is 16 by 13 into 1 by 0.5 milliampere. That will be your 32 divided by 13 is 2.46 milliampere. So what did you, can anyone comment? What did you observe from these two examples? What is the fundamental thing you should be clear about in any circuit? Even in later stage in transistors also, when even Professor Patil will move into transistor, we'll have one session regarding VGTs and MOSFET circuits. So what do you see here? See, what we see here is, if we have control over or knowledge over the node voltages, right? If we have knowledge or control over the node voltages, then we are good to go. We can find any branch current, any branch voltage, right? Do you agree with me?
Yes, sir.
So it is very important for us to know about the node voltages. See, this problem, how much time did you take? 30 seconds? Just because we knew the node voltage of VB prior hand. So be very careful, and in future circuit analysis also, you should have control over the node voltages. You should have the knowledge. Okay, let's move on to question number 10. I think it is pretty straightforward question. It is given, one expression is given. We need to find out the coefficient, this coefficient and this coefficient. How do we go about it? We assign a node voltage here and we use KCL, right? Take any direction. Let's say all are coming in, right? Then what will be using KCL? What is the equation at node A? V1 minus VA by 1 plus V2 minus VA by 1 plus V3 minus VA by 1 plus V4 minus VA by 2 equal to 0. Because all are coming in, no current is going out. This is our convention. You can take any branch coming in and any branch coming out, right? So answer C. Let's see. So just due to the multiplication, it will be 2V1 plus 2V2 plus 2V3 plus V4. And how much VA is there? 2, 2, 2, 6, and this is 1, 7. So it will be 7 VA, right? So your VA will be 2 by 7 V1 plus 2 by 7 V2 plus 2 by 7 V3 plus 1 by 7 V4. So the coefficient K1 and K2 is 2 by 7, 2 by 7. Do we have any option? Yes, B. So Raja, the answer is B. Please check again, right?
Sir, can you go to the previous slide 1 minute?
This one?
Previous, sir.
This one?
Yeah, okay, sir.
Yeah.
Yeah, thank you, sir. Yes, sir, you can continue. You can.
Okay, fine. So moving on to this is problem number 11. So what they have asked, if the current in the circuit shown figure is plotted versus voltage, which gives a straight line, right? I agree, because it is a linear circuit. What is the intercept of this straight line? On the V axis. So this is my I, this is V, right? So I need to plot I and V. How do we do it? We use KCL at this node A, right? Node A, KCL. What is the current? Incoming current is I. Outgoing current is, this branch current is V by 1 kilo ohm. What is this current? This branch current? Anybody? What is this branch current? This we have written here. This we have written here. What is this?
IS plus 1 milliampere.
Yes, right. Because it is a current source, so it will force any condition to haywire and it will maintain that the current through this branch is current source, the same value as of current source, right? This is the definition of current source. So we'll have 1 milliampere, right? So how my equation is looking like? Y is equal to V plus 1. This is my milliampere axis. This is my volt axis. So when V is 0, I is 1. When I is 0, V is minus 1, right? So we will have a straight line like this. Okay. What is the question? The intercept of the straight line on V axis, this point, right? This is minus 1. So D is the right answer. This is one way to go about it. What would be the other way to go about it? See, any V, this I and V, right? When you are asked to get the intercept on V axis, what is the value of V? Anyone? What is the value of, sorry, I? What is the value of I?
1 ampere.
No. At this point, whenever, see, this is,
0.
right, whenever this will cross this axis, I is 0. Clear?
Yes, sir.
So now let me redraw the circuit. Now let me redraw this circuit. This is I, this is V, this is 1K, this is 2K, this is 1 milliampere. What do you mean by I equal to 0? What did I tell you? What current source equal to current 0 means? What kind of circuit it is?
Norton circuit, sir.
No. Current source 0 means it is a open circuit, right?
Yes, sir. Sorry.
It is an open circuit. So if it is an open circuit, understand very carefully. The same concept I have explained in the Thevenin case. If it is an open circuit, this voltage is equal to this voltage, right? And my equivalent circuit becomes this, only this. I do not have any I component because I is 0. So this is my only V. This is 1K. This is 1 milliampere. Can anyone tell me what is, this is 2K. Can anyone, this current will flow around this loop, right? It has nowhere to go out. What is the V? Can anyone tell me?
V is equal to 2.
The V is between these points.
No.
1 volt.
Sorry?
1 milliampere minus multiply 1K over 1.
Okay. But what is the sign?
Sign will be positive.
1 volt, sir.
No. Sign is negative, right? See, your
Negative.
current is going from this point to this point.
Positive to negative.
No, current. See, it is a resistance, right? Current is coming in I. It has a voltage V, and this is R. Then V equals to IR. Okay.
I.
V equals to IR, right? Now, if it is a resistance, this is V. Current is going out. What is V? V equals to minus IR. Isn't it so? Isn't it obvious? Okay, just let me give you another example. This is Vs, this is R1, this is R2, right? What is this voltage? Just let me give you numbers, it will be better. It is 1 volt. It is not 1 volt. It is 10 volt. It is 4 ohm. It is 6 ohm. What is this voltage?
10 volt multiplies 6 ohm by 6 ohm plus 10, 4 ohm.
So what is this?
10 volt multiply 6 ohm.
No. What is this? What is the value? You can simply see, right? It is 6 volt.
Yes.
How
sir.
are you telling it is 6 volt? Because your current is coming in, right?
6 volt. 6.
Right. Current 1 ampere current is coming inside the terminal, inside the positive terminal.
Yes.
That is why it is positive. What is in this case? In this case, current is coming inside the negative terminal. See, note this sign. This current will flow in this clockwise this direction, right? So current is coming from this side, and I am asked to use this convention. This is V. See, it will be minus 1 volt. Is it clear now?
Yes, sir.
So it is minus 1 volt. Now see, did we have the same result? This is mathematical approach, right? This is physical approach, circuit. What I did is nothing. This equation I find out, and then I see the intercept at v-axis. That is one way to do it. The same thing which crossing the v-axis means your I is 0. I is 0 means I just open circuited this. I make this I not valid. If this I is 0, then my this voltage V is snapping into these points, between these 2 points. This is my voltage V. And if this is my point, then this current has to flow in this loop only. It cannot go out because it is open circuited. So this current is flowing in this way. So that drop across this becomes 1 volt. These are the same thing, but just 2 different representations, right? So moving on to the next thing, it is the same. That what is the intercept on I-axis? We have already calculated it mathematically. It is 1 milliampere, right? So your answer will be 1. Oh, it is wrongly written. It is 1 milliampere. Now see, intercept on I-axis means your V is 0, right? How to make V 0 here? What do we mean by V0? What do we mean by V0? Anyone? What kind of circuit it should be?
Short circuit.
Right, short circuit. Who told that? It is absolutely right. It is, if it is short circuit, then I just short it, right?
Yes, sir.
If you have a short, see, this is my I. Remember, this is my I. if you have a short in parallel with any kind of resistance, we can simply ignore the resistance because current will take the lowest resistance path and short circuit has zero resistance.
Yes, sir.
So this current will flow this way.
Yes, sir.
And this I will be equal to just 1 milliampere. Isn't it so?
Yes, sir.
So that is what we get from the graph, right? This is 1 milliampere. So this is the circuital approach. So they have asked what is the, if a resistance is connected between this, suppose a resistance is connected, what is the value of R that will be maximize the power absorbed by R? That means I need to find out Thevenin equivalent of this circuit, right? And the Thevenin equivalent will be a voltage source VTH
0.7.
this, right? But do I need to find VTH? I do not need to find VTH. They are asking just R. So I need to find just RTH. Okay.
Yes, sir.
So how do I find RTH? I just make this go away. Then this becomes open circuit. What is my RTH between this resistance only? Because this is open circuited.
Yes, sir.
Did you get it?
Will we answer this question?
So looking in RTH will be simply 1 kilo ohm. So C is the right answer. So see, you may not need to find VTH also sometimes, right? That you need to be very cautious about, that you do not need to calculate so many things in some questions. Okay, I think we are almost there time to, this is also the maximum power. I think this kind of questions I have solved. Okay, I think here we'll stop. See, you have any questions? You can ask now. I think we have 5 minutes. I'll share this slide. If you have any question regarding today's session or any topic you want to discuss, any clarification.
No, sir.
So how is this? This is basic.
Sir, can
thing.
you share this? Sir, can you share
Yes,
this?
yes, yes.
in
This
the
will
chat?
this will be shared.
Okay.
Even I will do these extra problems also for you, and it will help you for your solving the assignments, right?
Sir, where can we find this material, sir?
This will be shared with you by the NPTEL team. If they do not share, next week Sunday I will share you the link. Is
Through
that
mail
fine
or
with you?
sir? Through mail or?
I will
sir?
share you the link in this chat box only. You can find it. You can access it anytime.
Okay, sir. Okay, sir. Sir, and this meeting recordings also, can you do it for me?
Yes, yes.
For us?
Recording I will upload
Okay,
it in some YouTube channel and I will share, right?
Yeah. Okay. Sir.
Okay. So thank you. If you have any question, we still have time. Any question or any doubt if you want to ask. See, these are the very basic circuit theorems, right? At the beginning, it may feel like you take some time to solve the circuits, but once you get the fundamentals right, like Arvind was asking between the how to calculate the parallel and series resistances. This fundamental is you look at the nodes, right? Between nodes. So these fundamentals you should be very clear. Why do you take maxima? Why do you take minima? These things will not only be valid here also, even if you do some software job or something else in future, these concepts will be very helpful. So I request you to do this course very diligently and attempt all the assignment problems. You submit it carefully. You get the feedback from Professor Patil. I think there is also one live session is arranged with Professor Patil. I suggest you please join with him. And if you have any doubt, you can ask him in that duration, right? In 9th, I guess that it is scheduled on 9th. I think you might have received the mail. Okay.
Thank you, sir.
Okay. Thank you. You have been a great audience. Thank you. We'll meet next week sharp 3 p.m. Sunday.
So thank you, sir. That was a nice.
Thank you, sir.
Thank you. Thank you.